Hey guys, welcome back. Today is the 27th of October. Sorry for posting this video late. This question is for the 26th of October. It's called Height of Binary Tree After Subtree Removal of Queries. Uh, this question took me a while. I was out with my family today, so I could get to it very late. Uh, yeah, it took me a good couple of hours. I spent a good 1 hour on it, and I thought it would be better if I just explain the code after I've solved the question. So that is what I'm doing now. Alright, let's get into the question. So you are given the root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array of queries of size m. You have to perform m operations which are independent of each other, and you do the following in each operation. You remove the subtree rooted at the node with the value query from the tree. It is guaranteed that the query will not be the value of the root. Return an array of answer of size m where answer of I is the height of the tree after performing the ith query. What this means, guys, is say we look at this example. You could see this is our initial tree. We have a query that says 4. So you would go to root, you would go to node value 4, and you would remove this whole structure from the tree completely, and you would end up with something like this. And what you're supposed to return is the maximum length, maximum height of the tree after removal of this node 4. So you could see here, you can just count the edges. It's just 2 edges, so the height of the tree would be 2, and that is what you return in your answer array. Alright, let's look at a different example here. So we have this tree here, and we have the queries 3, 2, 4 and 8. Let's see what happens when we remove the node 3. So if you remove the node 3, after removing this, you would still have the maximum tree with length 1, 2, 3. You could see 5, 8, 2, 4 forming the longest string, or the longest tree branch. So you will return 3 here, and of course you are counting the edges here, not the number of nodes. So this is 1, 2 and 3 edges, so we return 3. And then if we remove the node 2, you could see that 1, 2 edges, this 5, 8, 1 would be the maximum length, and you would return 2 here. Again, you're counting the number of edges. There's one thing to note, that when we remove 3 and then try to remove 2, after you're done doing this operation is completely independent of the previous ones and the ones after it, so that once you do the operation with 2, the tree goes back to its original form as it is, like this, and you just return the answers here. Alright, so how did I solve this question? I had to maintain 3 maps. There's something, let me go into the code and try showing it to you guys. So I'm maintaining 3 maps here. There's a map which stores the level of each node, another one that holds the height of each node, and maxer, which is like at which level, what are the 2 maximum values at that level. Alright, whoops, sorry. Yeah, so let me go back. If I talk about the level map, you just take the node 5, you know it's at 0, so you store it there. Actually, I can just show it to you. So if you look at this example and you see my output here, you see that 1 is at level 0, so you store that here. You see that node 2 is at level 2, so you store it here. Node 3 is at level 1, and so on and so forth. You maintain the levels of each node, and then you also maintain the level, you maintain the heights of each node. So you could see 1 is 1, 2, 3, or in this case I've taken a node based indexing, so I've written 1, 2, 3, 4 as the maximum height at node 1. At node 2, you see there's no other elements below it, so I'm just maintaining the height as 1. At node 3, you can see there's two nodes, so there's the height there would be 2. For 4 it would also be 3, because you have 1 2 3 4 5 7, and then similarly for 5 6 and 1. You maintain the heights of this, and now the maxer uh, the maxer map hash map, this is storing the maximum values at that level. So you can see at level 0 we have only one height, which is for height of node 1, which is 4, and the other would be nothing, 0, because there isn't anything else after that. For level 1 you see there's 3, and the height of 3 is 2, and for level for node 4 it would also be 3 right here. So you store 3 and 2 in their descending order, and similarly for 2 at level 2 and at level 3 you maintain all of this. And what you do is, when you suppose you're removing the node 4, you check if your node is in one of these, if the value is lying here, and if it is, you would just take the height of this node, the other node that is after it, and you would add the level to it. So if I had to remove this node completely, I would check the height of this node 3, which would be 1, as you can see here, 3 plus 2, but I'm removing 1, sorry, I've done like my indexing wrong here, but yeah, you remove that and you get 1, and then you add the level of the tree. So this is at level 1, so you add 1 plus 1, you get 2, and that would be your answer right here. Alright, yeah, let me just quickly show you the whole code. This is a recursive function. At first I am just checking if my node value is null, I'm returning 0, otherwise I will put the node value with the current level. So this is just storing the level. Then I'm doing the same for the left and right nodes, and calculating the maximum of the 2 and storing that at that node. And then I'm putting the heights in the correct place. I'm maintaining the current the max values correctly. So the first max value, the second max value, and I'm doing some basic operation with them to figure out which one to pull out and which one not to pull out. Here I'm just maintaining my answer array, my 3 hash maps, calling the recursive function once. I've written down some printing statements to figure out if my code was working right, and then there's this for loop where you just go over the queries. You get the current element height, you get the current element level, and you figure out what's the first and the second, and you do this simple operation here and return the answer. Alright, yeah, thanks for watching, guys. Sorry this video was a little bit all over the place, but I'm sure the one after this would be better. Alright, thanks for watching.